On the previous lecture, we considered four main directions or application of using AI in cybersecurity. And on this lecture, we consider two first in more detail. I will plan to consider the first and the second issues again. Okay, so the first is AI-based use of AI in cybersecurity, the first. And the second, AI-based cyber threat landscape. So this is truly speaking, I will talk about the attacks, yes, against cybersecurity. And number three, this is some examples of my research. This is a previous research about this multi-agent technology which I taught. And I had also two presentations which I had last week in the CampsNet. One of them, sorry, not this, but one of them was the base paper for the workshop. So this is a current level of state of the art and using AI for defense. Yeah, so we are doing. But of course, in my lecture, the main goal is to show the broad picture. What is the main research nowadays in this area, and what is the main results, and what is the main, if you are working in this or planning to work, so what is interesting things to do, yeah? Okay, so the first AI for cybersecurity. The first is very important that this is an area is data-centric. So we need to know where to get this data. Yeah. So the first is so-called internal cybersecurity data sources. These examples. So the first is, for example, data source could be workstation or virtual machine images you could see in this table. Some data storages which had information, networking devices, network-based fingerprint and print data, NetFlow data. Do you know this? What NetFlow is? Yes, there's this tool which tries to fix the traffic and the parameter. So alert and event logs, vulnerability assessment results, and other data. So this is you see there's some description. Example platform which could present this data, and sample meta data and other kind of data. But again, this is a root data. This is not data for the ML. Yeah. So to have this ML, we of course need to somehow pre-process the data. So we need to include these labels, for example, for events. Yes, or of course we could use it using unsupervised method. So Professor Abhinav told about this. Yeah. Anyway, this is a sources of information which we can use. The other so-called external cybersecurity data sources. Again, this is very important because this is data which we need to use for processing, for using AI. Yes, and this is, for example, we have a system. We have such kind of different. Again, I can return to previous. So we have these devices, and we need to get this data. So, for example, we already pre-trained it, and we need to add data. Or we not pre-trained it, but we need to process the data and then using for the learning, and then including in our system, and then getting the real data and using the previous data for this data. Yeah. So this is a direct data which are not needed for. This is additional data or external. So this is data which could be used. For example, hacker forums. Yeah, some of them. Yeah, I will not read every from this table. So hacker forum. Why this is important? This is because we can get the information about exploits. existing exploits, yes, existing and maybe some kind of actions of hackers team. So this is important from the point of security, yeah. So a huge quantity of information sources could be used for this. So this also very important, for example, malware repositories. Yeah. So in case of previous lecture, I talked about this attack against Kaspersky lab. Yeah. This is a well-known VirusTotal, well-known library for the researcher, but this is also very important information for the training, for the using, and so on. Okay, then main cybersecurity application areas. So in previous lecture, we considered maybe main applications, main security mechanism where we can use it. But here, this is a main application area. So this is maybe the complexes of tasks which are used in the cybersecurity. So the first is cyber threat intelligence. So this is a task to get information about threats which are existing. And there are different tasks, for example, for malware analysis, for phishing, and other. There are different data sets. These are just examples of this in the table. Some tools and who was the first in the research in here, and some and also who was the first in industry. Yeah, so you could see that. And the second, this is disinformation and computational propaganda. So this is a number 4 direction which we have seen in previous lecture, but this is also could be important information for us. And the third, the security operation centers. So these centers which manage the situation in the networks. This is very important. And this is a real systems which join software, hardware, people, and which are used for the protection. So this is why they have such kind of name as a security operation centers. And the last, this is adversarial machine learning. I told this that this is important direction now. You see that some intersection is previous, yes, for direct. But this is again, they are we are living in the same world, yeah. All these things are intersected, so it is hard to select and to find something that's separate, not together, yeah, with all the things. Okay, and what is the main drawback of the current AI-based security research? So this is maybe the point I selected then. So this the first is this is isolation of this work of these two, industry and researcher. So usually, for example, researcher, the main goal is maybe to defend the dissertation, or maybe to have a publication. They are not maybe very interested in the implementation. This just for the, but company or industrial partner would like to have the tool which could be sold. Yes, so they have a stuff, but they work hidden, so they didn't discover what mechanism they use and what is the main development. So this is a usual situation. But how they be combined? Of course, some of the researchers could be the workers of some companies. Yeah, and in this case, they need to save the secrets. Yeah, so this this is a really interesting situation when a good work have done in the companies, of course, but we don't know about this. Maybe we have just some tools which work, but a lot of hidden information about this. And if, of course, they work together, so we had maybe more powerful result in science. Unfortunately, this is a situation not only in cybersecurity. Yeah. Of course, this is deep issues for the professors, not for the student, but this is a real analysis of this. The second, we lack data. The second problem, we really lack data. So this, for example, if I need data about, so I'm developing some new way how to use maybe diffusion mechanism for intrusion detection. So this with maybe some new attention mechanism for the for the transformer which I use. But I don't have the data, and I cannot get the pre-trained systems for this if I use, for example, LLM. But as a security, I'm limited, so I couldn't use the common tools as a ChatGPT, because this security things, and this is confidential data. So you understand that? Yes, situation. So I need maybe I'm working about intrusion detection and maybe 5G or 6G systems, some elements. Yeah, but I need from company this data for operation of this to do this. But this is data not open. So how I need to do this such kind of results in the security. So you see, of course, I can generate the synthetic data. I started my lecture, previous lecture about this. But again, this is some limitation about this. This is synthetic. This is not real. So there are some mistakes. There are some maybe discrepancies in the real and the artificial, which I try to generate. I don't take into account on all the law of functioning of the network, of the protocols which I used. So this is very important. The third is this is a model sharing and interpretation are key issues. So of course, I need to exchange the models, and this is very very important to have a good interpretation of this. And the fourth is there are not enough resources for the job. This is, for example, for me, there is maybe there is a problem which I need to solve with a supercomputer. But supercomputer, this is not my resource. I need to pay the money. That's in research. So something like this, yeah. So there are a lot of problems here. And a lot of good researchers go to the company. There's better salary, yes. But they usually the main their skill is a good to have a good publication, good journals. Yes, yes. But there are they in the company there is another way of the skill. Yes, this is practical. So they need to transform their activity. So this is important. So of course this is real, this is objective things which we need to take into account when we're doing the research. So the major areas for future AI in cybersecurity research, we could separate for several maybe also direction. The first, you see this, it should be, of course, multidisciplinary approach here. We need to have this AI-enabled decision-making, cybersecurity applications and data, and advanced AI mechanism or methods which I used. So this, for example, about this AI methods, so the multi-view and multi-model analytics, so this we need to use a lot of different approach. We need to know where is the best method could be applied. So this requires a lot of research, of course. What is maybe optimization technique for the resources for them? So this, of course, this is a black box mainly. This, if you we use ML. So in this case, of course, Professor Abhinav told about this. Very important. This explainable, interpretable AI. Yeah. Also, this you see augmented intelligence and human AI interfaces. So this is would be my next version tomorrow. So this is would be a visual analytics approach. It's very important because besides automated tools, we need to have a good interface for the people, for the operators. And so this should be some combination of automatic and analytical visualization tool. And we now finalized the book, the big book for the visual analytics. So it would be this big book with a lot of things. So this is a result of experience of my team in such kind of way. So this I will show on the next lecture different interfaces which I used. Very interesting interfaces. So this, for example, one of the interfaces. This is grass and the cow on the grass and the heaven, and so this is such kind of user interface for this augmented intelligence user AI interfaces. And if something happened, so this suddenly this is raining or cow running or something. So this why is this important? This because a lot of parameters, and we need some top level picture to understand for the situation. So this maybe this is some jokes, such kind, but this is was the idea of some researcher from Japan. This to connect nature with the technical things. Yeah. Okay. The other AI enable decision making. So also a lot of procedures should be. You see here this cybersecurity visualization and also a dashboard, automated cybersecurity prediction. So we need to do this, and the solution about defense and resilience and a lot of them. Okay. So this quickly. The next issue is open access test beds for cybersecurity. So there are a lot of them. So this is connected with issue of data-centric approach and with synthetic data. So we could use such kind of, so we could remotely have access to some of them and to use them in our research. So you see this some reference. Of course, this presentation will be. So if you in your research will need this, maybe this not all. There's some of them. There's some well-known representatives of such kind of open access test beds. Also, of course, there are a lot of open data sets. So we could use these data sets. These some examples, for example, data sets of 2016 years. Usually they are devoted to some of the sub-problem, for example, IoT, industrial IoT, or something like this, and they include some kind of attack, some kind of protocols, so you use it. You can use it. So another data sets, this is Canadian data sets you could use. It's well-known Professor Garbani from the Canada. So this is often used. So a lot of publications there are. This is some distribution in this work. There is a distribution of different approaches in cybersecurity for different neural networks, which I use. You see that number one here, this is RNN, recurrent neural network. So this is because it is so one of the representatives of course of this LSTM. Yeah. So and why they are very often used? This because we need some sequential actions. So that's why in the Professor Abhinav, he showed the architecture of the LSTM. Yes, and why this is very important for this sequential process, which have a repeated structure of processes. And some examples of work which are used here. So you see this different areas. So different kinds of deep neural networks which are used, and different kinds of data sets which are used to this. I don't go to deep detail. This is there are some novelties, advantages, limitations on every. But you need to say that they also, of course, separate according to data set that's separated for different areas. For example, for SDN, for wireless networks, for the Internet of Things, and in other ways. So this is a very important, of course, issue that's using DLL for encrypted traffic analysis. Of course, we have a problem with encrypted traffic analysis because we don't have access to the maybe payload of the protocols. But here also using this, of course, we have open headers. We have a common structure of behavior, so we could use this. So there are some very successful attempts. For example, in some case, you see this accuracy is very high, could be done. Okay, and also Professor Abhinav told about this deep reinforcement learning. In cybersecurity, this is a good examples of work where such kind of approach have been implemented, and some of them have also good results, good examples. This is just interesting to see how to about explainable and interpretable AI approaches. Also, a lot of different models can be used. I just skip. So this is the same picture, and all of them are used for cybersecurity. For example, in the November, I was a chair of the conference for the AI industrial applications in China. I was, and there was several papers about this using explanational approaches for the neural network, and one of my paper also was about this. Augmented intelligence human interfaces. So this would be tomorrow's lecture, but some of the examples of them I will show in this lecture. So just for to show this connection to the cybersecurity and the very important aspects of this. So usually this technique use several possibilities, several functionalities. The first is the filtering. So, for example, if you need to know some information, you don't need all this information. You can't understand anything. You need to filter, and the same as when you're doing some kind of search in the internet. Yeah. So this is important. The second, selection and linking. So you need to see the connection between different events. Something. This you see this list. Maybe this scaling, so you need to maybe to see enlarged, or maybe in the small to see the whole event. So this is important. So this action are very important for the user interface. This is some examples of different interface. Again, this is what would be in the tomorrow lecture. I will consider such kind of interface. So this is important how to understand. Yes, so this is a network and cybersecurity information which are depicted in different commercial tools. You see several tools and how it is depicted in different tools. So we see maybe the most interesting points. Maybe this could be from one port to another port a lot. It could be example of denial of service attacks, or some another event. So this is very important. Again, I go very quickly because tomorrow it would be deep analysis of this. Different models could be implemented here. So you see. And of course, if expert work with this and he understand this, he very quickly could understand the situation. So this is why such kind of visual analysis is very important. This is a so-called graphical representation with subway map. So it is clear, show the traffic ways in the system and some of the point which could be interested from the point of protection. So that's why such kind of hybrid interface is very, very important. Also this way, again, tomorrow I will tell, today we have a shift, yeah, this time. Also to show the situation with the different devices and the connection and the ways of the attackers, how they connect to different devices. Okay, and I also, in this topic, I will show, maybe in the last issue. So I'm planning to show you these two presentations from the CompsNet. Okay, in the end, because they, of course, connected to the use of AI in cybersecurity. But I also have this outer research, so this I will tell about this in the in the issue 3. Okay, so about this AI-based cyber threat landscape. So this is truly interesting. So of course, this is people who doing the bad things against us, and we need to protect. But what is now we see, this is very interesting. Maybe this is the best solutions in the world how to implement attacks. So if we analyze, try to do the data forensic. So the solution when the people would like to, this is truly genius who doing such kind of research. Usually they not publish their work, but the researcher who try to understand this, depict this, and you see this. This is a genius solution for some of the tools for doing the cyber attack. So now we are going to very smart cyber attack. So there are different names. So the smart attack, AI assisted attack, AI based attack, and others. So this is a kill chain. So this reconnaissance, assess, delivery, exploitation, and C2 action. So you see this kill chain, but here this just 5 phases. So we have seen 7 pages and 15 pages. Yes, so this 5 pages, 5 phases. This is just how to consider on the attack. So we could combine together some phases, and we could have such kind of selection. But for each phases, we see what kind of AI-based approaches we can implement. For example, the first, reconnaissance, intelligent target profiling. So we could intelligently select the goals for attacks. So maybe we could collect information and decide that what is a weak point in the network through which we can go. In the I'm telling it from the side of the malefactor. Yeah. Smart vulnerability detection, the same. This is a way how to hidden and very quickly to find the main vulnerabilities in the system. This. Intelligent collection, automated learned behavior, so the same. So this is a phase of reconnaissance. So the collecting information, how to efficiently to do this job. Maybe some of them, just example, intelligent capture, attack manipulation. So of course you know this capture. What does it mean? Yeah. So we need to maybe to get access to some of the application, and the system would like to define if it is a human or it is some robot, automatic tool doing this thing. But if this is automatic tool, yes, this is agent, yeah, but agent should be smart. That the system define it as a human, yeah? So there's this different way how to do such kind of capture attack for this one. So there are some examples. Of course, I can describe every of them, but for you, it is. I would like to just your main understanding that there are a lot of ways how to do this. So AI technique analyzed. So also on one of the work, they analyzed what kind of deep learning mechanism are used and what is the prevailing. And interesting in this work was the conclusion that mostly used CNN, yes, convolutional neural network. Interesting, but of course this was maybe not very big selection of the work. AI techniques so I select just one of the stages. So in the work of the Gamble, you see here. So there was some specification of different technique about reconnaissance stage, how to do this. And this is, you see also what kind of work we have in the access and penetration stage. Again, I don't go into detail, but this just example. For example, if we're using traditional targeted cyber attack decision logic, so this simple script we have, so this automatic agent will go, so this start, is this a target? Yes, execute attack, and not. But if we use AI, so in this case we have AI neural network, and we decide in what cases to do this attack. If maybe this is not good place for the attack, what kind of attack implement? So this multi-parameter decision making. So this we use neural network to define the parameters of the choosing the goal and what kind of attack to implement. So this is not simple previous approach, which we use. If you remember, I talked about this our environment where we implement multi-agent. So the first was very static, predefined scenarios. But then the next generation I use it now such kind of approach. This is using a system for the password guessing. So also they use a gun. You see this, and using two ways of gun. For this, so architecture of pass gun using generator architecture and discriminator architecture. As usual in the gun, we see this. And they fulfill this task to select the good password for the getting access to the system. Okay, I just skip this. So and about the outer research based on artificial intelligence. So the first, I'm telling about our maybe long playing tool which we are developing in my team. So we started developing it in the end of the 90s. And the idea was to prepare this multi-agent system at first for intrusion detection. Then was the other project to do this such kind of system for attack. And then a third project was to do this combined system which implement attack and detection in one system. So we could play with this and to see how it is behaving, what is the best strategy, for example, for attack, for defense, and so on. This at first, again, it was some predefined scenario. Then we, after several years, we implement ML, machine learning for learning them. And in the last time we implement also this LLM. So now this agent could ask LLM what to do in some action and also to define these solutions. This is a picture how to use different simulation alternatives, what kind of tool there are for simulation here. And one of the best approach, of course, packet level simulation. So we really simulate the protocols. So we use header and the payload for them, for each protocol, and we analyze when we doing the attack detection. So we analyze these protocols, and this is very close to the reality approach. So about this teamwork approach or the agent-based approach. So this we have basic mechanism for task work. So this maintenance of action coordination. So we have in several agents and that, some mechanism how to coordinate their work. Then monitoring and restoration of agent activity. So how, if in case of, so this is some enemy, there are enemy who could destroy agent, but we need to return the activity of the agent. So we need to mechanism for monitoring the state of the agent and then restore the state of the agent. So this truly this is a mechanism for cloning agent. And maintenance of communication selectivity. So this is very important. When agent fulfill, they coordinate their activity and then exchange messages. But when they exchange messages, the monitoring system which seen on this agent can detect it. So this idea that they should hidden this, so they minimize the conversation between each other, so the exchange. So this is very important. And maybe they send messages when this is a safe way, or maybe this is very necessary to send for changing maybe situation or to do the action. So this.
For the last one, it should be some kind of authentication.
Authentication?
Yes. And reducing the amount of communication.
But this is, I'm talking a little bit about another things. I'm talking about this messages, but how to do these messages, about, for example, how to trust messages. This is, yes, the aspect, for example, authentication. So, for example, how to exchange and then to define, to verify that this is a message from the agent which really needed in the, this cooperation, yeah? So this is a little bit another question. And for attack and defense, of course, we have a lot of parameters to define the work of the team. Therefore, some of them for attack realization, some of them for defense. Some example of the team. So this is a usual simple team of botnets. So on the first lecture it was, so we have several bots. We have a manager, master, and we have some agent which cooperate this team, this group of agents. And the goal of the bots maybe to do attack against some victim. So this is an example of the the set of agents which are doing attack against something. So for example, this could be the distributed denial of service attack. Yes, we consider this. And this is some examples of metrics of, for IRQ channels and some parameters. I just skip. This is architecture for network ontology and for representation of agents. So this, in some of this architecture, that we different agents are situated. This is, could be distributed around the world, this system. and exchange, and in different they could be in different subnets. So you see this maybe this you see dark blue, and this device is the agent situated, and different strategies. Again, of course, to describe this should be a very long process, not for this lecture, but the main understanding of this, there are different defense mechanisms. How to in this this traffic volume for different traffic volume for different aspects in the time. And now this example of the scheme of the acting. So when, for example, several groups of agents cooperate, one of the attacking, the other protecting. And the goal they are attacking to destroy the protecting agents that they couldn't protect the system. And so, for example, we are trying to, at first, you see this attack start. So you see here this attack traffic, and we try protection agent trying to understand. In this case, they detect. So this attack. So this from the side of the attacking seeing this, they change in strategy, and then again they prevail in this attack traffic to do this action. So this example of behavior of the agent and counteracting when somebody trying to block, and then after changing the strategy, the other. So this is some kind of game of life between the teams of agents. So this is interesting. This this is a game of life because this is as in life. There are different species. They are trying to prevail in. They're trying to spread in. But this is not simple process because a lot of species, and yes, so the same as a human, some of the species very developed, so they prevail in the world now. But previously it was maybe some of the species together with others existing. Yeah, the same. That's why such kind of way in the. So if we see in the future and AI-based, maybe not good future, when automatic AI win the humankind. Yeah, so this some idea when such kind of agent exists and fulfill their action, then also separated for some groups, and so this is also some maybe in theoretical sense interesting problem. But of course we are interested in the simulation of different attacks and defense mechanism and seeing what is a better strategy for protection against. This is main idea. Okay, and at the end I show just maybe it is interesting for you. I showed two presentations where we use AI-based mechanism for detection of attacks, and I just quickly show what kind of network architecture we use and what kind of results we have for different applications. This is just again just to show, not go to detail, but to show what we have here. Okay, so one of the work, so this was on device AI security solutions. So this idea was to study also the Professor Abhinav told about this some combinational approaches when we are trying to build some hybrid system which combines several detection mechanisms. Yes. And in this case, so this for IoT, I just quickly to show. So idea to minimize the resources which I needed for this tool. So this is this is why we call it as on-device security. This is on-node functionalities which we have. So this in the ML usually we call this pipeline. Yes, ML pipeline. So we have several procedures for pre-processing. So this is data standard dimension reduction. This is undersampling. So this, in some cases, this is because some kind of attacks, data about attacks are very low. So we have a very unbalanced data. So we need to this pre-processing to have it. We have here 3 classifiers. We try to use different combination mechanisms for these three classifiers. You see on the picture this scheme, and so and we evaluate them. So the main solution. So we use first this dense neural network approach and several CNNs. So with different architecture. The first is a separable, so-called CNN. So this is architecture we use for our experiment. You see here. So this separable CNN and CNN with special spatial parameter pooling. So we investigate how to use such kind of layer in the network and how it is behave. And also we investigate. I just call it this is main algorithm how to use it in this the architecture of this. And we, of course, the main goal how to imply the combination mechanism. So this voting, we use voting algorithm, so this specially crafted. So this weighted average voting and stacking algorithm. So we just a little changed it. So we change this voting and the weighting average voting. So this we a little bit change it. So this algorithm here, I don't go detail, just to show this how we the other people, not only me, but not only my team, but the other doing this research and what kind of solution they are developing. So they are here, for example, can be used some of the data sets. So we use this Age IoT. This is pretty well fresh data sets. You see this in the table, different kinds of attack. If you see this fingerprinting and the MITM, so this middle in the man in the middle, they are have a very low such kind of attack in the data sets. So you see this share, yeah, below here. So usually this is very hard to detect such kind. If we have in data set this, that's okay. But this. So this is we call usually call this imbalance problem. So this idea how to do the another data sets, usually on the pre-processing, how to do another data sets, which try to maybe minimize the majority classes and enlarge the minority classes. Here it is. Understandable. Yeah, that is usual for the ML. So this we are truly doing this approach as a 5-fold cross-validation approach. So, and now this is some results. So we investigate. You see this different kinds of networks, and also this combination, this method. So this stacking and this voiding. That's our approach. And in the results, we see that this is not no method which prevailing. Yeah, this usual. When we're doing research, and this is some results, some conclusion about. So, for example, the main conclusion: overall, the assembly method outperform all basic method. This is usual because we get the best results from this. But of course, this is very important about resources, because on the device security we have a very low resources, And that's why we use such kind of architecture. So this is a simplified architecture, but we try to do the most effective and to minimize the resources. So this is the main. Of course, there are some particular conclusions about the different. So in different conditions, different methods work better. This you see. And another experiments, for example, this is experiments for different kinds of attacks. You see this different kinds of attack, how this method behave and detect for different kinds of attacks. And the main conclusion here also this overall. So this again, especially it's taken its best approach, and also for different conditions we could see the result. So this is a good example of research for the intrusion detection, and usually the researchers are doing such kind of research and select what is the best mechanism could be applied here. And maybe at the end, just another book, good example. This is a previous CAMSNets. Also, this is a work of my team. So what is the difference? So this is an unsupervised method. So this is was invited paper. So they especially invite me for this conference. And the idea, I just very quickly go this. Maybe the idea again to show this unsupervised mechanism. So the clustering. Dr. Abhinav told about this, yeah. So this DB scan he described, yeah, this means, but we used BIRCH. So this balanced iterative reduction clustering using hierarchies. BIRCH approach, this is a good because we could structure and we could have a constant number of clusters in the system. So this is interesting. And also we combine it with deep learning mechanism. So again, I don't go to deep detail, but idea to use the sequences of action and frames. So this is a not new idea in the research world, but new idea for the cybersecurity to implement here. I just skip. So this yes, the procedure includes 4 main phases. So what is interesting for this approach? We don't need training. We could implement this approach for any system with processing the system. But of course, we need pre-processing. We need to adjust the parameters. This is very important things for the clustering. So we need correct distribution of clusters. So this is very important. Again, of course, maybe this is very hard to understand. Yes, very quickly. But this is just, again, an example of the unsupervised learning that it could be used for the cybersecurity. And what is interesting, here we use not separate attacks, not separate actions, but we take into account the sequences of actions. We build the so-called frames. I will show this. So again, this again 4 phases. Because I didn't describe. The first is security event clustering. So I did the task. Then generation of so-called graph models. Then graph prediction and anomaly detection. So we trying to prognose the action. We have real data, so we build these graphs, and then we compare the prediction and the real graphs. They are represented as the frames of graphs, so the sequences of graphs which include the changes of the system states. And we define if it is new attack or not. So this all. This is important in such kind of system. So this, you see this, for example, why we use Birch, because we have a constant set of clusters, and what is the headache of this approach? So we need to play with parameters. So we need to adjust these mechanisms at first. So this, okay. There's a lot of works for research, okay, and using also deep learning. And I go to the experiment. So experimental data, this is industrial Internet of Things. So this water cleaning systems. And we consider these different attacks. Interesting, this is what I call this frames of graphs. So we have maybe state of the sequences, and the changing in the time window, and we change in this time window for one. So this is a technique when in the internet we consider not only one point and not a whole sequence, but we select the window and shift it. So this, for example, the events or traffic, but we see this time window. This is because the first limitation of the resources, we couldn't see all the picture. The second, there is attack which are only the windows. There are this very quick attack, and there is a very slow attack. So, for example, in window we couldn't cover this, but we change it. So this we save the history. Okay. So very interesting, also explainable. So this is a way when Dr. Abhinav described the mechanism about pre, in, and post explanation. You remember this slide, yeah, for him. So this is in and post explanation. So this is not together with the mechanism. This is some additional mechanism which allow us to explain the solution which we do. Okay, so this is good examples of the work which are doing and using AI in cybersecurity. Okay, so this is the end of my lecture. I try to shrink it a little bit, yeah, because we shifted a little bit. But of course, maybe most important not details, but to see the systematic way what things are now in the cybersecurity, what kind of mechanism are used for AI in the cybersecurity, what kind of areas exist. So this, I select four areas, yes. And one of the people very famous in this cybersecurity also telling that, but this is not correct classification, because if you know this classification, when we're doing classification, we don't have a clear separation between classes here. Yes. So this, they are intersect. But anyway, they allow us to understand the situation. The next, my lecture tomorrow will be about the visual analytics again. I hidden some detail here, some slides, but on the next lecture I will show very interesting pictures for you, how we could depict different information about the cybersecurity. Okay, thank you. I'm waiting your question if you have.
Can you shift to slide 15 on this one?
On this? Yes. 15? Next.
Previous one. Even this is work. This generation, like this RAC graph generation, exactly like you would be taking the source code of the program and then generating the graph, or how are you exactly generating the graphs for a process? Yes, I have asking here.
So this is a short description of the approach, yeah? So this, you see, so we use the first step, the cluster analysis, yeah? And we need to determine the similar relationship of events. So for us, the input is different events.
Okay.
Yes? And we try to maybe to cluster these events, several events, in one graph.
Okay.
So this, we call them as a representative security event graph. So this you see here. So usually this one. So he described the situation and transition between different events in some time period. So this, when we have this real sequence of the events, we have this. But our task is so-called predicted RSA graphs.
How are you exactly gaining this data for the predicted RSA graph? I understood how you are reaching to the true RSA graph. How are you getting this predicted one?
So for predicted graph, we use this is a representative. So I can show you this picture. So this input as event, we have sliding window. Yes. So then we have a set of time window in each. So just very quickly, I'll show you this.
The frame slide, right?
So yes. So this you see this. Here this. So we have a lot of events. A representative security graph. This is the center of the cluster. Okay. So we built. So for example, when a system really functioning, it is have a lot of events. So they are maybe in the some place near this. Yeah. But the central point. This is a point describe this point for the representative. So representative for us, this is a normal behavior. Okay. But when we have a real graph from this, so we have maybe point here, maybe there. When we build the predictive graph, so we just use the center, and we see this difference between the real, yes, for each event. So this what is a we have not one event but sequences and connection between them. So we consider this frames. Okay. You understand?
Understood. So this centroid would be representative of all the event in that sector, right?
Yes.
So are there chances that the predicted RSA graph could be inconsistent considering what centroid we are choosing?
Yeah, but we use not only one event. We use sequence event and connections. So we consider the maybe this a set of events and connection between them. So these frames, and we compare these frames together, real frames which we have and predicted frames. So it could be the mistake.
So because that would lead to
but because we have the whole picture, several, so it is nivellated a little bit. So, but of course, this is a heuristic approach, yeah? So, now this, we are improving it. We trying another mechanism, but for analysis, for experiments, we got the good results. But this is some novel approach, how to behave this. And again, this is unsupervised mechanism. So we don't have learning. That's important. Yeah.
Thanks.
Any other questions?